Hey class, this is Mr. Schmidt. We're talking about the last part of our review with springs and power that were covered in the 5th quiz. Okay, so the question is going to ask about spring force, spring energy, and power. This is one version of it, the one we went over in the review. So I noted, don't pay attention to this height here. That height does not impact the second part of this question, the one we're dealing with. Okay, so I jump off the deck onto a trampoline. The trampoline compresses 0.6 meters with a constant of 5,000 newtons per meter. What is the spring force? Okay, and then we're going to find the spring energy, and then finally the height. From what I saw, people are able to do the first two parts fairly quickly, so I'll just go ahead and show those answers, and then we will talk more about how do we do the setup for the final part. Okay, so let's share over to the paper. Okay, so this is the paper I wrote in class. You're not going to see anything different. So notice we have our person at initial height. Because I'm not dealing with conservation of energy with some of these points, I'm not going to worry about that initial height. That's something we could have asked. But the idea is the trampoline compressed 0.6 meters with this constant. Okay, and our final question is going to be, what is the height? First thing we wanted to find was the force. Okay, so this was the upward force of the spring. The next one is the energy of the spring. So again, that one was fairly straightforward as well. Okay, make sure you're using the equations listed. Make sure you're using the AP Physics equation sheet as well as your notes to have all these constants. Okay, then we had the jumping from here to here to here. So the idea is at point 1, all the energy was conserved. Okay, from point 1 to point 2, energy is conserved. So we can look at all the energy we have right here, and then we can find out how much energy we have right here and how is it expressed. So we can go through all these points. Again, you want to write them all out and you want to compare them. So notice when we had two different objects, we had two different potentials, two different kinetics initially, and then two final potentials and two final kinetics. Okay, so that increased the number of variables we had. When there's only one object, we have one initial potential, one final potential, one initial kinetic, one final kinetic, one initial spring, one final spring. Some of those go to 0. Okay. There will be some points in the middle there where all of them could have been present. When the spring was halfway compressed, then we would have had to track all of those. That is not something I asked at this point. Okay, all right, so we know this energy. Okay, at the top of the arc, it is not moving and it is no longer in contact with the spring. So that all that is left is our potential energy of the of me, I guess, jumping in the trampoline. Okay, so we look at how high up did I go. I went up 0.92 meters. Okay, so the algebra again goes fairly quickly. This is where you have to really take your time, draw as many diagrams as you need to figure this out and to track all of this. Okay, if you look at work I do in class, it ends up I've done like 30 pieces of paper a day doing our physics. And I've seen some of you try to do the last exam all on one piece of paper. And your mistakes here were because you tried to compress things, okay? This is not an Algebra 1 class. I'm guessing that you're going to be able to do this step, okay? This is not supposed to be the hard step. This is where we're supposed to be doing our thinking at this point, okay? So make sure you stop and you think about this before you go on. So this will be our last video for semester 1 of AP Physics. Good luck on your exam. Remember, we will not have a Zoom meeting during the exam. You'll just download it, use your class time to take the test, and upload it that day. Email me if you have any questions. Okay, and with that, good luck. Thank you for participating and trying and sticking with it, and we'll see you all second semester.